I am Slater Jones, and I'm going to teach you how to do a means two-sample confidence interval. So, in a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random into two groups of 30 patients each. One group received a beta blocker, the other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2 and a standard deviation 7.8. For the control group, the mean pulse rate was 70.3 and the standard deviation was 8.3. Construct and interpret a 99% confidence interval for the difference in mean pulse rates. So, the first thing we would have to do is find the parameter, just like the other problem. So first we find the parameter. In this equation, we see here that there are two means and two standard deviations. So what we have here is a two-sample confidence interval. Two-sample confidence interval means. So we would have two parameters. The first parameter, mu1, would equal the actual average pulse rate of patients during surgery when given the beta blocker drug. The second parameter would be mu2, and that would equal the actual average pulse rate of patients during surgery when given a placebo. So, next, because we are finding a confidence interval, we do not have to find the hypothesis. We go straight to conditions. So, for the first conditions, we find mu1. First, we will find the 10% condition, and it is greater than or equal to 10. And there are, so for the equation, we see that there are 30 patients each, so that means there are 32 separate samples of 30 in this equation. So we would use 30 as our sample size. And this would equal n is greater than or equal to 300. And so we assume that there are more than 300 patients in the population. Next, we will find that the sample is random if you read the equation. The patients have been chosen, or as it says in the equation, the available subjects are divided at random into two groups of 30. So that would mean that the sample is random. Lastly, find the normality condition. So this is 30, and this should be greater than or greater than 30. They both equal each other. They both equal the same, so this would be normal. So the normality condition has been met. All right, and then we find the next conditions for the second sample. So we do the same thing. We find n is greater than or equal to 10 times 30, which equals to n is greater than or equal to 300. We assume there's more than 300 patients. We assume that the sample is random because they have been divided, the patients have been divided randomly. So sample is random. Lastly, we find the normality condition. See, 30 is greater than 30. They both equal the same, so the normality condition has been met. Alright, so next we find the description. Because this is means, we use t and degree of freedom. In this, the degree of freedom is sample size minus 1, which would be 29. And because we are looking at confidence intervals right now and we do not know the parameter, we just put mu. So we find now, with this, we find the standard deviation of both of the samples. And that would be